welcome to Easy BTech, your guide for BTech and beyond. Easy BTech helps the students to know the concepts of various engineering subjects in an easiest way, and they can prepare well for the examinations and score very good marks. So, in the previous video, I explained you about how to find the components of the individual forces and also the procedure for finding the resultant. So, in this video, I explain you a problem to find the magnitude and direction of the given coplanar concurrent force system. So, in this particular case, four forces are given here. 50 newtons, 15 newtons, and 18 newtons and 20 newtons are given. And 50 newtons is making an angle 30 degrees with x-axis, and 15 newtons is making an angle 45 degrees with the x-axis here, and 18 newtons is making angle 60 degrees with x-axis, and 20 newtons is making an angle 15 degrees with the x-axis. So all the forces here are making angles with the x-axis here. So when I taken the 50 newtons, I told you that when it is making an angle with x-axis, x component is always the force multiplied by the cos of the angle. So for 50 newtons, so first you draw a table. Okay, the first column is force, the second column is fx, and the third column is Fy. Okay, this force table is to be drawn. For 50 newtons, the Fx is 50 cos 30 degrees, and this one is 50 sin 30 degrees. 50 cos 30 degrees and 50 sin 30 degrees. Similarly, the 15 newtons also. So here also this is making an angle 45 degrees with x-axis. So it is 15 cos 45 and 15 sin 45. Similarly, if you taken the 18 newtons, it is also making angle with the 60 degrees here, and 18 cos 60 degrees and 18 sin 60 degrees. And 20 newtons is also making angle 15 degrees with x-axis. Here x component is 20 cos 15 degrees and y component is 20 sin 15 degrees. So here we write the components here. So this is 15 cos 45 degrees, and here it is 15 sin 45 degrees. And 18, third one is angle is 60, 18 cos 60 degrees and 18 sin 60 degrees. And here the last one is 20, the 20 cos 15 degrees and 20 sin 15 degrees. So now we have written the magnitudes here. So when it comes to the directions, first 50 newtons, it is in the first quadrant here. So both are plus. Okay, there is no need to write. So 15 newtons here, this is acting in the second quadrant here. The x component is acting towards left, and y component is in the upward direction. So this becomes minus, this is minus, and this one is plus. And the third one is, here if you look at this x and y component, both are minus. So this is minus and this one is also minus. So both directions are minus. And 20 newtons here, and here x component is plus and y component is minus. So this x component is the plus and y component is minus. So you can write the values also here. So the 50 cos 30 degrees and 50 sin 30 degrees and 15 cos 45, 15 sin 45, 18 cos 60, 18 sin 60, and 20 cos 15 and 20 sin 15. You can take the values, and so after that, if you multiply with the respected forces, you get these values. So after that, all the x components and all the y components can be added here. So if you add all these components, the sigma fx will become 64.24 newtons. And sigma fy, here it becomes 14.5 66 newtons. So one is sigma fx and sigma fy. So after this, we can find, so in this one, we have calculated what is the sigma fx and sigma fy. Okay, the first two steps are over in finding the resultant here. The sigma fx is 64.24 newtons here, 64.24 newtons, and sigma fy is 14.86 newtons. Okay, so from the tabular column we got both these values. I told you that how to find the magnitude of resultant, resultant force, and R is equal to, so it is root over sigma fx whole square plus sigma fy whole square. Okay, this is how you can find the magnitude of the resultant. And now if you substitute these values, so 64.24 square plus 14.86 whole square here, so this comes to the magnitude of the resultant here. So this is 65.93 newtons. And now you can find the direction of resultant. Direction of resultant. So as I mentioned in the previous video, the tan theta is equal to sigma fy by sigma fx. So here both the values are known to us. It is 14.86. 14.86. So divided by, it is 64.24. So this is the tan theta value. So tan theta value becomes 0.23. So tan theta is 0.23. So now this theta is tan inverse 0.23. So this value, when you calculate tan inverse 0.23, this is 12.95 degrees. Okay, so here first what we did here is all the forces are divided into its respective components. So it is a coplanar concurrent force system. We found all the x components and y components. When you add all the x components, we got sigma fx, then we got sigma fy, and this one is the resultant. So this is a single force which replaces all the forces and has got the same effect. So here we got 65.93 newtons. And so here if you look at this one, direction, so you got 12.95 degrees. And in this case, you can represent the resultant. So now this resultant is represented like this. And here both are positive here, sigma fy, sigma fx. So this is sigma fx, and this one is sigma fy. Okay, one value sigma fx, another value sigma fy, and this is equal to 64.24 newtons. Okay, and when it comes to sigma fy, so this is 14.86 newtons, and resultant is acting. So this one is the resultant, and this makes an angle of 12.95 degrees with x-axis. So this is how we can make the entire force system is equivalent to this resultant. So in this way we can find the resultant, and I hope you have understood this solution. You can apply the same procedure for any kind of resultant problem for a coplanar concurrent force system. Thank you.